Hi! Fuzzy logic has been applied in many AI technology around the world, and it is one of the promising ways to handle uncertainty. What is fuzziness? According to the Oxford English Dictionary, the word fuzzy means blurred, fluffy, frayed, or indistinct. However, in Malay, fuzzy is more known as kabur, samar, atau kurang jelas. So, what is fuzzy logic? Fuzzy logic is a deterministic uncertainty. It is connected to the degree which events can occur. It is not about how much it likely to occur or probability like we look in naive Bayesian. However, it is more describing how much does something belongs to something. For example, the degree to which a person is young. How young is a person? To define fuzzy logic, let's see how we use common sense when we solve problems. Experts usually use vague and ambiguous terms in solving problems. For example, an expert might say, though the power transformer is slightly overloaded, I can keep this load for a while. How are we going to look at the value of slightly overloaded and how long is for a while? Can we represent these terms, which is vague and ambiguous, into computer? Fuzzy logic is the theory of fuzzy sets that we can use to calibrate vagueness. In fuzzy logic, a set of mathematical principles for knowledge representation are based on degrees of memberships. Unlike this two-value Boolean logic, which have only two values, true or false, on or off, 1 or 0. Fuzzy logic is a multi-value thing. It deals with the degree of membership and the degrees of truth. It uses the continuum of logical values between 0 to 1, which 0 is completely false and 1 is completely true. Instead of just being two values, black and white, it employs the spectrum of colors, accepting that things can be partly true and partly false at the same time. This representing the gray area where some vague values lies in our daily problem. Since knowledge can be expressed in a more natural way by using fuzzy sets, now many engineering and decisions problems can be greatly simplified. If you use Boolean logic, there is sharp distinctions. It forces us to draw lines between members of a class and non-members. For instance, we may say Tom is tall because his height is 181 centimeters. If we drew a line at 180, we would find that David, who is 179 centimeters, is small. But if we think logically, David and Tom is just 2 centimeters apart. So is David really a small man? Or we have just drawn an arbitrary line in the sand? So we can see that having fuzzy logic helps us to represent things more naturally. So, fuzzy logic is based on the idea that all things admit of a degrees. It belongs to a set in some degree. Okay, so temperature, height, speed, distance, beauty, all comes in a sliding scale. Okay, the motor is running really hot. That is the word that we usually use. Tom is a very tall guy. How are we going to describe the very tall guy? Okay, electric cars are not very fast. We don't have fast and not fast. We have not very fast. Okay, high performance drives require very rapid dynamics and precise regulation. In all of these sentences, we can see that every values are described with linguistic values. So these knowledge needs some kind of formal kind of representation in computers. The question is, how are we going to define these fuzzy values to be understood by the computers? You can see this set. We have three sets here, which is short, average, and tall. How are we going to define these fuzzy values to be understood by computers? In this graph, we can see the height is defined by centimeters from 150 to 110. And we have some kind of degree of membership 0 to 1. In the normal set, this is not a fuzzy set. In a normal set, a crisp set, we have three sets, short, average, and tall. So someone with 158 centimeters will be considered as a short person. Someone with 175 centimeters height is an average person. 184 is a tall person. But if you are using fuzzy sets, you can see how much you belong to each set. For example, 158 is a short person. 175 is an average person. And 184, it lies in the intersection between average and tall. However, this person belongs to average group only for 0.1, which is 10%, and he belongs to the tall group at 0.4, which is 40%. Now we can see what is the differences between a crisp or Boolean set with a fuzzy set. A crisp or Boolean set is always a precise properties, while fuzzy set have very imprecise values. The membership in crisp is always full, yes or no, true or false, 1 or 0. But in fuzzy logic, we have partial membership. We can have yes until no. The truth value can be totally true up to totally false. And the value is between 1 to 0. It is no longer a full membership, only one value. In crisp set, in Boolean set, the values are always exact. For example, if we look at the variable age, the values is 13 years. Height, 1.5 meters. In fuzzy set, we can say she is about 13 years. Maybe she is 12 years and 11 months. Maybe she is 13 years and 2 months. So it's still accepted that she is 13 years. However, it can be a vague value there. The same thing goes with height. This person is about 1.5 meter tall. So when we talk about, so this person can be about maybe 1.48 meter tall, maybe 1.45, or maybe 1.52. So when we try to model the models in Boolean or crisp, we call it crisp. We always have crisp relations. Meanwhile, in fuzzy, the relations are fuzzy. We'll look at these differences in detail in our next video. Thank you for watching.